Let's take a look at another sorting algorithm. So this is different from selection sort. So we're going to be doing an insertion sort in this video. So it's a sorting algorithm where we remove, doesn't matter where it comes from, but any item from the unsorted collection. Because it's unsorted, really, it doesn't matter where it comes from. And we're going to insert it where it belongs within a sorted collection. So these are the important things. So if I have, this is my sorted array, and I am about to take something from this one. It doesn't matter which one I grab, but usually I either remove them from the end or remove them from the beginning. In this example, we're going to be removing them from the beginning. So if we take the 3 out, what it's going to do is it's going to scan through and find a position that is, or a value that is larger than it, and then it's going to insert and then move everything over. So this is the algorithm that we're going to write. You should definitely, if you haven't already, check out the selection sort algorithm before we start, because it contains these 2 functions that I've got. So at the top, make sure that you include the vector and time libraries, and then maybe pause the video so that you can create this function that is going to randomly load some number of values into an array, and this one that will display the contents of the array. So pause the video now if you need to, and then you can go ahead once you've got that done. In the main program, we're going to be dealing with some random numbers. So we'll put the randomization line here at the beginning. And then what we'll do is we need to create our vector int numbers. And then what we'll do is we'll load random numbers. We'll put 20 values in it, and then we'll display it. So display numbers. Okay, we'll run the program. So this is what you have, is this sequence of 20 random numbers, and this is what we are going to be sorting. So in order to do that in the main program, what we'll do is we'll run a function that we're about to create called Insert Sort, and we'll be working on numbers. And then when we're done, we'll display it again to verify that it did sort those values. Okay, so let's go above int main. We'll create insert sort. So void insert sort, and we're receiving the vector as a parameter, and don't forget to put the and sign here so that it will be a reference to the original and not just the contents of it being sent. And in order to do this, what we'll be doing is we will be assembling a sorted array, and we'll call it temp because we only need it to insert the values into. We also need to keep track of the value to be inserted. So we're going to be removing a value and then putting it into the other one. So as we create this, we are going to be slowly destroying the original array until it has nothing left in it. And then we will be kind of like switching them over. So we'll be putting all the values in temp, and then we'll dump them back into n. But by the end of this, n will be empty. So we've got to do a while loop, while n.empty. Now this is the opposite of what we want. We want this to be false. So we want it not to be empty. This is again the not symbol. So when it's not empty, it is going to be doing the following. So first thing that the insertion sort has to do is it has to remove the value from the original array. So remove the first value from the unsorted array. Okay, and then we're going to be doing this in this way. So the value is going to become always the first item. So the first item is always n position 0. So that's always going to be the first, and then what we're going to do is we'll remove the first. So n dot erase, and then which position? N dot begin. So we're removing the beginning position of the n array that is holding our numbers. Now what we have to do is potentially we could have an empty temp. So I'm going to do it this way. So if temp dot empty temp.empty, then what we're going to do is we're just going to push back the value onto it. So temp.push back the value. So this is only what we do for when we are putting our first value into the array. We don't have to do any searching for it. We just drop it right there. So otherwise, what we're going to do is we're going to need to find where to put it. Otherwise, find where it needs to go. So in order to do that, we need a for loop. So this is going to traverse the temp array. So while I gets the value 0, whoops, while I is less than temp.size I plus plus. And now there are two possibilities. Either we find something that is larger. So if temp I is larger than the value. So in our traversal, we encounter a value which is larger than what we are trying to place. That's where we need to place it. So this is the situation where we found a larger value. And then it'll indicate where we're putting it. Otherwise, we need to check to see if I is equal to the temp.size minus 1. And this means that we reached the end. So reached the end without finding anything larger. So if we reach the end and find something that, nothing that is larger than the value we're trying to place, this is, we're just going to place it at the end. So this is the easier one, temp.pushback. So if the value we're trying to place is larger than any value in the array, we are going to put it at the end. And then what we want to do is we want to break out of this. We want to break out of this for loop because we will have done our placement job. Now, when we find a value that is larger than the value we're trying to place, say if it's in position 3, then I want to put the value in position 3 and then shift everything over. Of course, we have insert to help us with that. So temp.insert, and this is going to be in the position of temp.begin plus I and comma value. So we're going to put in the value in, we're going to move I positions from the beginning of our array. And then, of course, we've placed our item, so we are going to break. Now, this is actually already done. I'm going to just fix this up a little bit. So what we have to do now is we have to, now that we've got temp assembled, n should be empty after it goes through this enough times. We just need our, make sure that I put this in the right place. It's got to be after the while loop is finished. And we'll get the value of temp. And that'll be that. So we'll run this just to verify to see how it's going. So we get our sorted array, same as, say, the selection sort. but it's a little bit of a different way of doing this, and there are small differences in like where you would want to use one of these versus the other, but that's a topic for another video.